1 of this series, we learned that the word mole was the name of a number, a very specific number, 6.022 times 10 to the 23rd power. In video 2 of this series, we learned how easy it is to determine the weight of 1 mole of atoms of any element. Simply go to the periodic table, look up the element and its AMU number, and then change the units to grams. 1 mole of sodium atoms weighs 22.99 grams. In video 3, we saw that not only can you have a mole of atoms, but you can also have a mole of molecules. And we learned how to calculate the weight of a mole of molecules by adding up the weight of all of the atoms. In this video, you will learn about molarity. Molarity is the number of moles of a solute that are dissolved in a solution. The units of molarity are moles of solute per liter. For example, if I dissolved 3 moles of sodium chloride in 1 liter of water, I have created a solution of sodium chloride with a molarity of 3. If I dissolve 2 moles of hydrogen chloride in 1 liter of water, I have created a solution of hydrogen chloride with a molarity of 2. And if I dissolve 0.5 moles of sugar in 1 liter of water, I have created a solution of sugar with a molarity of 0.5. To reinforce our visual comprehension of molarity, let's prepare a solution of baking soda and water with a molarity of 2. The first thing we need to know is the weight of 1 mole of baking soda molecules. The molecular formula for baking soda is NaHCO3. 1 sodium atom, 1 hydrogen atom, 1 carbon atom, and 3 oxygen atoms. So, if we want to know the weight of 1 mole of baking soda molecules, we need to know the weight of 1 mole of sodium atoms, the weight of 1 mole of hydrogen atoms, the weight of 1 mole of carbon atoms, and the weight of 3 moles of oxygen atoms. Well, after watching video number 2 of this series, we know how to do this fairly easily. First, we look up sodium on the periodic table. Then we change the AMU to grams, and we find that 1 mole of sodium atoms weighs 22.99 grams. Let's round off that number just for the sake of convenience to 23 grams. Now we do the same thing with the other atoms that make up a molecule of baking soda. We'll round off hydrogen to 1 gram, and we'll round off carbon to 12 grams. The atomic mass unit number of oxygen is 16, so we know that 1 mole of oxygen atoms weighs 16 grams. But remember, we have 3 oxygen atoms in each molecule of baking soda. So if we have 1 mole of baking soda molecules, we'll have 3 moles of oxygen atoms. 3 times 16 will equal 48 grams. Now let's add up the weight of all the atoms that are contained in 1 mole of baking soda molecules. And our answer is 84 grams. So 84 grams would be the weight of 1 mole of baking soda molecules. But it's important to remember that we are preparing a 1 liter solution with a molarity of 2. So we will need 2 moles of baking soda, and that will weigh 168 grams. Now let's go to the lab and prepare the solution. First, we will weigh out 2 moles of baking soda. We will use a volumetric flask to make the solution. A volumetric flask is used when a precise measurement of the volume is required. In this case, we want a precise measurement of 1 liter. There is an etched ring on the neck of the flask marking the 1 liter volume. We first pour in the baking soda and then the water. The last few milliliters are added using a plastic transfer pipette. We keep adding water drop by drop until the bottom of the meniscus lines up with the etched ring. Now we mix the baking soda and water to dissolve as much of the solute as possible. But even after an extended period of inverting the flask to mix the contents, we can plainly see that much of the baking soda has not dissolved. What we have discovered is that it is not possible to have a solution of baking soda with a molarity of 2. The solution is already saturated, and no more solute will dissolve. So let's go back to the whiteboard, and this time let's calculate the weight of 1/10 of a mole of baking soda, which is very easy to do. We just move the decimal point 1 place to the left. So if the weight of 1 mole of baking soda is 84 grams, 1/10 of a mole of baking soda will weigh 8.4 grams. So we weigh out 8.4 grams of baking soda. We pour it into the flask, and then we pour the water into the flask. And once again, mix the contents. This time, after we invert the flask several times, we can see that all of the baking soda has dissolved. Now we have a homogeneous solution of baking soda and water with a molarity of 0.1.